virtualization is? Virtualization is a level of interaction between your operational environment and physical hardware where that operation environment runs in on top. Key benefit of virtualization is share hardware resources between different environments, operating environments, running on the same physical hardware, and also additional manageability added in fact by that level of interaction. So let's discuss how you could virtualize your physical server, which ways you can use to virtualize. Hardware emulation, it's virtualization where your guest computer running using virtualized hardware provided by another host operating system. Paravirtualization is virtualization where guest operating system in fact modified somehow and doesn't work with hardware assuming that it is real hardware, but instead making special calls to the host operating system. And virtualization on operating system level, it's virtualization embedded in the operating system itself. So operating system itself is able to create multiple virtualized instances of that particular operating system. And basically that's what OpenVZ is about. So let's just see different solutions, different technologies, how they implemented in different solutions. Hardware emulation. The most popular is definitely VMware. One of the oldest ones is probably that Bosch. Maybe if you know, there are kind of different approaches of hardware emulation. Simplest one, or maybe not simplest, but most like fair way, is just emulating all the processor instructions one by one. That's actually what this one is doing. But it's really very slow. I heard feedback that Windows starts on such emulated computer about 40 minutes. So you can imagine 40 minutes just in order to start operating system. VMware uses slightly different approach. It doesn't allow, doesn't emulate every single CPU instruction. Instead, it allows most of them to run natively on CPU, but still having full control on the computer and kind of interrupting its execution and replacing some instructions when needed. So, pros, contras of those approaches. Advantage: you can run any operating system and you don't need actually to modify anything in operating system. And also you can run different operating systems on the same physical computer. Disadvantages is low density and scalability. So what is low density? Basically you have a lot of overhead because you need to load separate kernel. That kernel accesses memory and uses it as the same way like it would be memory physical computers. So that means its own buffers for block devices, own cache of the file system, and so on, own memory management. Scalability, that means your hardware, your CPUs, your memory is kind of emulated. And as example, it's really complicated in that technology to emulate multiple CPU computers. So your computer may be single CPU, your virtual computer may be 2 CPUs, but it's currently it's impossible to have it like 16 CPUs. And if you really need powerful server, which uses all the available power, like 16 CPUs, it's impossible here. So that's not the way how you would virtualize servers with really big applications like some database servers with a lot of users accessing it. It's not going to work in that way. When performance, which is maybe addressed, but still a lot of overhead, and complexity of the management, because in fact, on top of single physical computer, you install like 10 virtual computers, and you need to manage those 10 virtual computers like it would be physical computers. 10 operating systems, 10 times to apply patches, install applications, manage users, and so on. Well, performance issue, just because of the emulation. The next approach is power virtualization, and then one of the most popular implementation of power virtualization. Another is well known is user mode Linux. So what power virtualization is the way to virtualize when you modify guest operating system. In case of user mode Linux, it's just standard Linux kernel, but mostly we've replaced drivers and some other part of kernel replaced. In case of Xen, it's normally Linux with some is also drivers which don't use directly hardware, but instead just makes a call to the host operating system. Advantages: better performance for sure, because less needs to be emulated. Disadvantages: you need to modify operating system. Still, most of the disadvantages of VM-based approach, like worse scalability, manageability, and still less performance compared to native operating system, and static resource allocations. So that means you don't really have a lot of control over guest operating systems. And it's complicated in that technology, like as example, memory, manage size of the memory on the fly. So you cannot really add memory without your virtual computer restart. Just an example. Okay, the next one is operating system level virtualization. We have many implementation of it. Like one of the probably oldest is FreeBSD jail, Linux vServer, Solaris zones, and definitely OpenVZ. So what is OS level virtualization? OS level virtualization is virtualization embedded in operating systems. That means operating system itself is not running on in some virtual computing mode. It's running directly on the hardware. But operating system itself is able to provide services in virtualized way. So that means isolate namespace, create more than one instance of operating system itself. So disadvantage, first of all, single operating system. You cannot use, in this approach, you cannot install, as example, Windows on top of Linux computer. You cannot use a different version of kernel where it's only one kernel. You cannot even load one more kernel. So, like, you cannot start the same kernel twice where it's only one kernel. Advantages. Native performance, first of all. Just because that guest operating system, in fact, it runs directly on the hardware. So from the host, you may see all the processes. You can see like network connections, whatever. So host has full control over it. Dynamic resource also advantages. Dynamic resource allocation and best scalability. Typically, for OS level virtualization, resource allocation implemented in form of just quotas, similar like Linux disk quota. So what that means? That means if you want to allow particular VPS to allocate more memory, you just set new quota on it, and that new memory becomes immediately available. That means when application running on that VPS in that virtual computer attempts to allocate memory next time, it will be immediately allowed. So nothing needs to be changed in order to allow to use that resource, because operating system itself, single operating system itself decides whether it's allowed or not for VPS to use particular resource. And certainly scalability, because there is no any limitation on how powerful your private server may be. If your physical computer has like 16 CPUs and I don't know, 16 gigs of or 32 gigabytes of memory, you can immediately allow application to use all the memory. So it's only a question of which limitations applied on that VPS. If no limitations, everything is available. Yeah.
今のところがOpenVZ のテクノロジーの部分だったんですけれども、何かご質問とかあればちょっと中断して大丈夫ですか?
So let's just discuss like that nature of operating system virtualization. Basically, if we will think about it, it's very natural extension of operating system capabilities. From very beginning, operating systems were single tasks, like DOS was single task. Only one task might be running at the same time. Then operating system became multitask. So that means multiple tasks may be running on same operating system simultaneously. But again, from very beginning, still single user. Then operating system became multi-user. So multiple users may connect to same physical servers and run the applications. And very natural extension of operating system capabilities is just to make it multi-instance. So simple multitasks, that means single computer running multiple tasks. Multi-users mean single computer running multiple users, and each user may run his own tasks. And multiple execution environments, that means just multiple instances of same operating system. Multiple instances, in each instance a number of users, each user may run own tasks. So let's just briefly see what is design approach of OpenVZ virtualization. Let's see that diagram. Hardware, networking, and host operating system. So just computer, Linux, And on top of it, OpenVZ, in fact, OpenVZ is embedded in Linux kernel itself. Then OpenVZ uses templates in order to create virtual environments. What is template is set of files which will be used in inside of virtual environment. What is advantage of templates? First of all, you may provision your VPS out of template. That means you can just create new VPS, saying something like, I want that template and I want to create VPS out of that template. And template may have different Linux distribution. You may have like host running of one Linux distribution and template using another one. Where is only one kernel, but guest and host templates and guest and host distributions may be different. And then each virtual private server has applications running, root user connected, and other users separated. So if that picture would be without virtualization, it would look like the following. No WIS level, no WIS level, and only one instance just occupying all the space. So all that physical computer and single environment on it. So OpenVZ just allows you, instead of that big environment, just create small one and still have room for other environments.
What is a common use case? Because the VMware usually use different kinds of operating system in the same box, but it's only one operating system, right?
Right, but different instances.
Yeah, but what is a common use case?
Server consolidation.
Yeah.
Imagine you have
use
10.
server consolidation, maybe SMPs, other SMP, large SMP is one approach. You don't need to use a different operating system or different instances.
You know, it normally depends. You may have different.
Excuse me.
Yeah.
We are recording a video, so could you repeat the question?
Oh, sorry.
Please, yeah.
Sure. The question is about why do you need that virtualization approach?
Yes.
Because you cannot run like multiple operating systems. So what is the reason why you may need more than one instance of the same operating system running on a physical computer? So let's just consider scenarios, what it can be used for. First of all, it's simplified provisioning. Installing physical computer, you need to normally, in the best case, you can use like bootp protocol and use boot from the network and install it. But normally what you do is you install that computer with CDs and so on. So you still need to go to physical computer, insert CDs, like do something. It takes time. Here it's very simple. You have that host installed and then new instances may be installed and reinstall it directly from command line. So you just go to physical server and type in command like I want to create one more server. Okay, then you need more, you create one more. Another usage scenario is server consolidation. Typically, server loads is in most companies is 10, 5, 20%. It's not often that server is fully loaded. In that case, you can just save on the hardware and put more than one physical server on more than one physical server inside of virtual, and have like 5 or 10 servers running on the same physical. It's very common that like in the same company you have 10 physical servers and all of them running Linux. So same operating system. But you still use those servers for different purposes, and you don't want to combine them on the same server. It may be security reason. Another reason may be applications are not compatible with each other on the same server. Another reason maybe you have different administrators dedicated for management of those servers. So with this virtualization approach, you still can do that. You still can combine everything on single server. So it solves applications compatibility issue. It solves management issue. And also fast provisioning of those services. So does it answer your question?
Yes.
I have a basic question.
Sure.
OpenVZ design approach same as BSDJ environment. So some what I/O hardware or network resources shares all entity. So I think one virtual environments using such for SSHD using port 22 TCP. Other virtual environment can use same port on same network.
Yes, it can.
That port resource what resources is shared or virtualized?
Okay, let's see what is virtualized.
Yeah.
So the question is about which resources exactly are virtualized and what is kind of level of compatibility of different applications and different like physical servers or virtual servers on the same physical server. So what is virtualized? First of all, processes. So processes running in one instance, they are completely not visible and not accessible from the process running in another VPS. So you cannot see processes, you cannot send any signal, you cannot, for example, kill process. Only from the host system itself, so from physical computer, you can see all the processes running in all the environments and can manage them directly. And also another great advantage is of that manageability is from the host system you can jump directly into a virtual environment. And it allows you to manage applications in all the VEs directly from the physical host. In VM approach, it's much more complicated because it's completely different operating system, and the VM is kind of black box for the host operating system. With operating system level virtualization, it's not true because operating system has full control over what is going on inside of virtual environment. So first thing, processes virtualization. Process visibility and the ability to one process to communicate to another one. Then inter-process communication, IPC resources, like shared memory, semaphores, message queues, also virtualized completely. So that means even from the host operating system, you cannot see resources allocated in the context of some of the VPSs. You only need to get in that context, and then you can check them out. But directly you cannot. And then one of the important part of virtualization is network virtualization. Let me just probably drive some pictures and just show how it. Okay. OpenVZ has two different approaches of network virtualization, and let me just show you both of them. First approach is IP-based virtualization, so it's routing-based virtualization. And second is emulation of network cards, so it's Ethernet device-based virtualization. So first, let's see how routing-based virtualization works. Okay, so this is our physical server. And these are our virtual instances. Virtual environment 1 and virtual environment 2. And here we see network devices. Network device called VENet. So VNet device here and VNet device here. And also on the host there is its own instance of virtualization, network virtualization device. VNet as well. And that virtual device has knowledge about virtual devices for all the virtual environments. So there are connections like that. And then there is Ethernet. On the host. And then there are just standard routing rules. So how exactly that virtualization works? Imagine there is process. Okay. Let's see. Let's assign some IP address on that VPS. Different VPSs normally use different IP addresses. Like 10, 10, 10, 1, 10, 10, 2. Okay, and now let's consider the following scenario. Some packet coming from outside the world to IP address 10, 10, 10, 1. So how networking works in that case? First of all, in ARP cache of that device, this IP address is added automatically when you start VPS, just static ARP entry. That means then ARP request coming, like who has that IP address? That device says, I have. And then packet goes to this device. Then it gets into the host operating system, and in host operating system there are routing rules, and for each VE there is a special routing rules added, which says that IP address 10. Then 1 should go to device named VNet. So this is a routing rule added on the host. So that packet is checked against that routing rule and then goes to VNet. And VNet is a virtualization device which is aware of virtualization and which has internal table with information like that. That IP address, that means VE1. Another IP address, VE2, and so on. So this is the way how VNet delivers packet here. And then application here may establish like connection or read that packet from VNet device inside of the VPS. So that's how virtualization, how routing-based virtualization works here. Basically, there is advantage of this virtualization model. Most important advantage is performance. We're basically zero copy of everything during that packet delivery. That means packet is not copied from here to here. There is only single packet created on the system, and then routing just, in fact, sets different references to that packet. At the end, packet becomes owned by that VPS. So performance actually as high as the performance of native networking may be here. But disadvantage is it's kind of strictly limited networking. That networking may be only IP-based. And you cannot, for example, assign same IP address to different VPSs in order to create a solution, like, for example, for load balancing. It's not allowed in that model because, again, it's routing based only, and in that case, it will not have knowledge like where exactly should packets be delivered. And also, it's impossible to use any protocol other by IP here. Like, you cannot have that IP address assigned by DHCP because that DHCP negotiation will not be delivered in that VPS. So in order to provide like full networking capabilities, there is another virtualization model for the network in OpenVZ.
So, question?
Yeah.
So can you use multicast or broadcast, or what the up?
Normally here in this model you cannot, but there is another model where you can.
So there are so many restrictions.
Right. I mean, you know, for most of the applications, that networking model is fine because when you just have some service running here or some application.
So can you have different ARP entries? No. What is the MAC address of which can be seen by some?
VE has no MAC address.
No MAC?
No MAC address. It's with connection is point-to-point connection.
So you cannot use IPv6.
No.
You
basically,
should say IPv4.
basically you can use, but that protocol should be virtualized as well. So it should be like virtualized in different way. Maybe it's similar, but still it's slightly different. And the protocol itself should be virtualized. So in order to just to get rid of all those possible disadvantages of limitation, again, advantage is it's works for like 90% of scenarios and it's high performance, but still some disadvantages because it's IP only. So in order to have like full capable networking, there is another networking model introduced in Virtuoso and in OpenVZ. Ethernet device-based virtualization. In that networking model, each VE has VETH type network devices. Like Ethernet but virtualized. And using basically network bridges as underlying technology, we create kind of virtual switches on that server. When after that server, that bridge, is created, first of all, you can plug your physical interface in that bridge. And then you can plug those virtual Ethernet interfaces in that bridge as well. So that networking model has nothing to do with IP level. It doesn't really care what is IP address assigned in that VPS and how exactly it's assigned. It only provides network connectivity. Yeah?
So what the MAC address?
When you assign that VPS, you can specify that MAC address manually, or you can use just some auto-generated MAC address. But here we do have MAC address.
So different instance should have different MAC address?
Yeah, sure.
Okay.
Like on normal networking. In fact, you know, that networking model is just emulation of physical network infrastructure. So you can consider WIS part as just wire and WIS as a maybe hub, network hub.
Is that model is very similar to VMware's switch model, right?
Sorry? Is
that model is similar to VMware switch bridge model の時に
okay.
That is similar to VMware's networks.
to bridge, exactly. And basically, in fact, WIS is bridge.
Software bridge.
Right.
Okay.
And bridge is what is used to emulate that physical infrastructure. And again, advantage here, it's much more flexible. as example, if you have second network card, you can have like another bridge, and you can add, for one of the VE, you can add another interface and plug it here. And in that case, in the VE, you can have, as example, router or firewall or whatever. In the previous model, it's not really possible, because for that firewall, you cannot just redirect all the traffic through that VPS. Or it's maybe really complicated, so you need to create like source-based routing rules. So really complicated thing. Here it's very easy because it's direct emulation of physical network infrastructure. Okay. Any other questions?
So what do you call this? I mean, the device level virtualized? You know?
Sorry?
What is the name of this model?
It's
name the both models. But anyway.
okay. The previous one was routing-based networking, and this one is Ethernet type-based networking virtualization.
Have you done with other protocols for routing-based?
Which protocols you mean?
I mean IPv6 because I'm working.
You know, I'll better get you in touch with guys who develop OpenVZ, and you can check it with them, because in Virtuoso currently we do not support IPv6 yet. So because we don't really have too much demands on it. As soon as we will have, we will support it. So I'm not really very familiar with IPv6 details implementation.
If the user needs to use other protocols such as IPv6, they need to use device level.
Or re-implement virtualization, routing-based virtualization for IPv6.
Okay.
It may be an option as well.
Or if they want to use multicast or some other advanced networking features.
Okay, and
Question.
yeah.
Can we set up without physical internet device, only a virtual network with a bridge model? For example, using something for heartbeat?
Yeah, sure, absolutely. I mean, you have voice connection,
Yeah.
and voice connection is not really required.
Yeah.
Yep. You just create another bridge, and you plug with the interfaces in that bridge. Okay, and last thing, which is virtualized, back to your question about virtualization capabilities, is file system. For OpenVZ, file system virtualization is very simple. VPS itself is actually a change root environment. So file systems are isolated just using change root. With Virtuoso, it's a little bit more advanced. With Virtuoso, we have a special Virtuoso-specific VZFS file system, which just allows to manage those environments in a more efficient way. What exactly I mean is with VZFS file system, you don't need to copy all the files each time when you create new instance. Instead, VZFS uses only links to that template area. So using VZFS, you have only one instance of your distribution or your application installed, and then when you need to install that application or distribution in VPS, you only create set of links to different files. And you still can modify any files inside of the VPS. In that case, VZFS will just transparently create copy on write. So all the modified files will be created directly inside of the VPS private area. Okay, so some more details about OpenVZ components. Kernel components. First of all, virtualization and isolation. Virtualization provides virtualized environments, and isolation allows you to isolate processes of running in one VE from processes in another VEs. And also resource management. Resource management is a way to control resource consumptions by VE. And in OpenVZ, you can control amount of memory. You can control CPU, so CPU usage between different VEs. And in Virtuoso, we additionally have traffic control, so traffic bandwidth consumption. In OpenVZ, as far as I remember, it's not there, but it's actually easy to implement and add it on top of it, just using like TC or similar technologies for bandwidth management. And last component, but still pretty interesting, is checkpointing. What checkpointing is a special kernel part which allows you to create dump of running processes. Just freeze them, and then later you can put that dump in file system, and when you need, you can restore those processes. And more importantly, you can restore those processes on another computer, on different physical computer. And that allows you to implement live migration. So that means you just freeze VPS on one physical computer and then unfreeze it on another one. So even existing network connection may be redirected automatically from one computer to another one, and user will not have any downtime. Even applications will not be restarted during that migration.
So checkpoint is freezing with execution.
Right.
Running execution on the way to point-to-point checkpoint down.
Mm-hmm.
So dumping data to transfer to another one, and restarting and switching can.
Right.
Can switch to one to another one. Oh.
Switching from one physical computer to another physical computer is not actually checkpointing itself. It's a set of tools around the checkpointing, which allows you to transfer that image from one physical computer to another one, and then just restore that VPS. But checkpointing is a way, in fact, what checkpointing is a way to freeze group of processes and just unload it from memory, and also load back from that image file back to memory, back to the memory.
So some application environments can running processes continuously. So checkpoint is prevent execution or not prevent while freezing.
When you freeze process cannot execute anymore.
Cannot execute.
After it freezed, no, it cannot. But it will automatically restores execution after it's unfreezed. So basically what that checkpointing is about is each process, when it runs, it allocates a lot of different resources. Like from very beginning, process only creates that task struct, if I'm not mistaken. It's called task struct, right? With 2 pages of physical memory and all the information about the process stored in it. Then process may allocate some memory. Process may allocate some using with different system calls some other memory for sockets, for open file descriptors, and so on. What checkpointing is a mechanism which allows to take like one process and check what exactly were all the resources, and just read all the required memory and just put it in the file in the proper way. And after that, it is able to reverse all the job. So just read that file and restore all the structures in the same way like they were originally created by the process, by that process itself.
Do you have any performance data from live migration from A to B?
You mean for how long the service will be interrupted?
Yeah.
with recent version of that live migration, it's less than second, like half second or something like that. You know, that process is actually a recent version of that migration very interesting. Let me describe like historically how it developed, and we had 3 different versions of it. Okay, the historically very first model was the following. This is one physical server, and this is another one, and this is a VPS that we are going to migrate. So here there is no VPS yet, there is only operating systems running. So step number 1, we just freeze execution of with the processes running in with processes running in inside of the particular VE. Okay, frozen, that means still in memory but do not execute anymore. After that, we create that image. And in fact, just kind of that footprint created. And stored in that file. So only file here. When that full file is transferred here, normally all over the network. So as soon as image is here, for now there is kind of not really downtime but service interruption, because with the process frozen. And any services, they do not reply. It's kind of, it looks like interrupted network connectivity. So we transfer that file when undump it and create that image here. After it was successfully created, what happens, which one is just removed from memory and which one is restored. So now it may execute. So typically, here downtime depended on what is it footprint of the memory and how long it would take to transfer it over the network. And for big workloads, it may be pretty long, like 5, 10, maybe seconds. For really big ones, maybe up to a minute. So it's not really good because network connection may be interrupted during that minute of the migration. So we created another one, which was more efficient. That model number 2 was transfer of that memory image on demand. So how exactly it worked? VPS is frozen and image is created. For now, it's only locally. We even do not create that image on the file system. It's still in memory, but it's accessible just like file. Then we transfer only small part of it. What that part is actually just a list of processes and a list of kernel structures, but without memory image yet. All the memory is here. But from that part, we already can restore that VPS, but only without memory yet. So it's kind of restored, but not fully restored. And then VPS is allowed to run. But as soon as VPS attempts to allocate some memory, attempts to use, sorry, some memory, which was pre-allocated, that memory is not available. And where is page fault happens? And it handled in very similar way how it handled in case of swap out. But instead of reading that memory from swap and putting it back in physical memory, that memory is actually read from the remote computer over the network. So less service interruption, but VPS may be kind of a little bit slow after it immediately restored. So for some period of time, it may experience some slowdown because some of the memory should be delivered on demand from the previous computer to the new one. So that was the model number 2. And then okay, sure. We designed that model number 3.
昔我々のカーネルあれでユーザーモード Linux を使ってライブマイグレーションをするとかいうなんか実装を作った人なんていう方でしたっけ？リチャードなんとかさんじゃどなたか覚えてないですかね？
いくらでもありそうなんです。
いや、ソフトウェアのスペック使ってマイグレーションしたっていうのは違うわけです。
いやだからカーネル読書会で発表してもらったっていうやつで。いや2、3年前。
Do you know what? No, I haven't tried personally.
2 or 3 years ago, we had a presentation which modified user mode Linux, which is actually that migration from server A to server B. And I don't remember his name, but Richard I don't remember. Yeah.
Okay, so back to the model number 3.
Yeah. Sorry.
Same VE. And same memory dump. So how exactly it works? First we create that memory dump, but we do not freeze that VPS yet. So instead what we do, we only mark that memory which was already dumped as memory which should not be modified. So the memory is here. And then we immediately start the transfer of that memory image to another server. But again, that VPS is still running. And that means VPS may modify some part of the memory during that period of time while it transferred that memory. And let's see, like when VPS was running, it modified like that part, that part, that part. Normally, it's less than the whole image. That means we can transfer that part here again, but still do it much faster because less memory should be transferred. During that period of time, VPS again might modify something here, but less again. So we can migrate it one more time. And we do it until that footprint of modified memory was really small. When we finally freeze that VPS, transfer final difference, and may immediately restore it. So with this technology, which allows us to have like very minimal downtime during live migration.
Maybe you can start. So you can mark some. You can start the new instance first. No?
New instance? What
Yeah,
exactly? What exactly?
So you can run migrated the instance on new server before actually translating the final difference just by marking some dirty pages.
Not sure I got the question.
Maybe you said that you stop first
Uh-huh.
and transfer the last difference and then restart. And then start on the new server, right?
Yep.
But maybe you can
最後まで一気に別に入らなくても
一番最後の瞬間を
最後の瞬間に切り替えるときほんの数秒とか一瞬必要っていうレベル
yeah,
です。
but we can even shorten the difference because just making some just marking some pages on new server. I mean だってさ、新しいマシン上でこのページはまだコピーされてないってマークをしておいて、で新しいスタートが新しいマシン上でスタートさせて後からコピーする。
started before he tried to explain a new idea on this architecture.
Yeah, yeah, I got it, but I'm not really understanding what the idea is.
So
Combine mode 2.
yeah, mode 3. Okay. In addition to mode 3.
Mode 3 to the mode 2 idea. Mode 2 is only transfer just part of the image and go to run and then background to transferring. Is right? So
Yeah.
He want to mention that just a part of transfer and marking only a dirty pages and go run and then backward transferring is more efficient.
You know, I'm not 100% sure, but very possible that it was implemented already because I know our kernel guys, they really polished that and tried like to do it as short as possible.
Okay.
So very possible it's
maybe
implemented already.
Your explanation is not accurate.
You know, my explanation is just like basics of that
Okay,
technology.
okay.
I'm not sure I know like all the internals of it.
That checkpoint restart system for the purpose of process migration only, I think in the area of high performance computing, on the way to computed results for saving because big computing was done. So checkpoints is can checkpoints is versioning. Version 1 on the way to 1, on the way to 2, on the way to 3. Some checkpoints can hold.
So you mean kind of using the checkpointing mechanism? Is it possible to have like replicated images of running instance of multiple different servers?
Yeah.
Uh,
No. Only one. In the only one physical host. So some version of images for checkpoint is free can hold because very big computing. So very hard arrays for big purposes. So calculating to atmosphere and so on. That's in these areas, users wish to save on the way to the last computed results because some calculating so many times needed in big computing. So but in some
you know, maybe you could explain in Japanese if you prefer. And,
いやだから、HPC とかの世界でこう大きい巨大な計算をするときにその途中結果を保存したいっていう要求ってきっとあると思うんですよ。ところがこれだとちょっとマイグレー ションっていうイメージで説明されてたんで、
みたいな感じ。
そうです、そういう意味での実行しながらのライブの途中経過を保存して、で何かの理由で例えば停電とかなんとかシステムが落ちちゃった時に、
incremental backup.
そうですそうです。
You can do that.
Virtualizer has incremental backup. あります。
So, no questions.
よくバーチャル仮想環境の中にアプリケーションをインストールして、でそのアプリケーションをアップグレードする前にインクリメントバックアップ取る。で、その新しいバージョンをインストールする。で、問題なければそのまま使う。で、もしそのアプリケーションのアップグレードでなんか問題があれば、先のインクリメントバックアップを使います。
それファイルの話じゃないですか。
全部まあそうですね。
メモリーは
Incremental backup is mainly just a file system.
Yeah, it's file system only.
Yeah.
どちらかというと、だからそういう話ももちろんあるんですけど、その計算結果を自動的にそのどっかに
それメモリのですか？
メモリの計算結果をどっか
それはモデル1でできてるんですか？
どっかに置いといて、それをその例えばシャットダウンかなんかしたときにまた、その途中経過から実行が再開できると嬉しいなとか、そういう話ですよね。
まあそうなんですけど、特にその計算リソースの時って、追加のカードとかになると思うんですけども、計算要素が別上にあって行列計算一気にやってるから、計算結果の途中要素って通常できなかったりすることがあるんですよ。そういう途中結果の状態をどこまで計算されたかわからないまま保存したいっていう用途っていうのは結局あると思うんですよ。例えば SMP とかでメモリ上で動いていると、どこまで計算するのかわかんないと。条件だけ待って次の計算をどんどんパラでやっていくなんていう状態の時には、そのどの状態でファイルに落としたいのかわかんないわけですよ。そういう時のそこまでのインクリメンタルバックアップができると、そういうハイパフォーマンスエリアでも使えるかなと思って。
でもそうするとさっきのモデル1をちょっと改良すれば、なんかいけそうですよね。
でもそういう用途って結局あると思うんですよ。何ヶ月と計算した結果がお釈迦になるためのセーフティーな保存って。
メモリ上のところです。
メモリ上ですとか全部のリソースのですね。動きながらっていうのが重要なんですけど。
So making a snapshot of maybe the processes and the memory for later usage or to check some problem that happened.
でもその瞬間止めざるを得ない。
止められないじゃないですか。行列計算パラにやったりすると。
サービスを伴ってて、そのプロセスとかメモリ全部をスナップショットして、So just like the service is still running, but take a snapshot of the memory, the processes.
Yeah, it is possible. I mean, technology itself allows it to do. I mean, after you completed that transfer, you don't really have to freeze that image. If you are not going to migrate it to another one, you can just let it to run, and you can read that memory that you want to read, and just store it in file and as.
フリーズ普通はするんですけども、フリーズをしないでそのまま動かし続けてどんどんやっていくっていうことが技術的にはもったいないんじゃないですかっていう。
証拠ができると結構そういう学上系とかハイパフォーマンスコンピューティングエリアで商売ができるんじゃないかなと。
これオープンソースなんでできれば。
Okay. What type of shared storage can use OpenVZ?
Sorry, what?
What type of shared storage? iSCSI or NFS
What type of storages
storage?
may be used? Basically, for the file system storage, it doesn't really matter.
No, shared storage for migration.
Oh, migration.
For migration
I see.
needs shared storage. Host A, host B, shared same storage image.
For migration, tools are able to transfer files as well. So tools normally just use rsync for the files transfer, and VPS may be still running while file system is transferred to the destination computer. So total migration time may be as long as it's required to transfer all the data across the network, but server's interruption is really short because files may be transferred, like last difference may be transferred later. And it is also possible, technology allows you to do that migration using just shared file system. But in that case, in case you're using something like iSCSI, you need to have also multi-host or cluster file system itself, because it should be accessible from different servers at the same time. So GFS or something like that.
OCFs too? You can use Oracle cluster file system too?
Whatever you have, whatever you can use, but still it should be a multi-host file system.
Thank you.
Okay, and back to the component of OpenVZ. Tools. VZCTL, this is a tool which allows you to control virtual environment and make all the operations like create, start, stop. VZPKG is application management and template management. So VZPKG allows you to create VPS based on some template, install updates from repository in VPS, or install some applications. And templates are just pre-created images in order to speed up VPS creation. So instead of installation packages each time when you create your VPS, basically they only package it once as a tarball and then unpacked as soon as you need a new VPS. Just much faster. This is basically a question which we already discussed. So which part are virtualized? Again, file system, processes, network, devices. It's not really virtualization, but kind of permissions management. So you can allow particular VPS to access particular devices on the host, or not allow. And IPC objects virtualized completely. Resource management. User bin counters, it's a way to manage resources. So it's limit on size of memory to allocate, number of sockets to create, number of processes to create, and so on. CPU scheduler. CPU scheduler in OpenVZ allows you to set priorities between different VPSs, and not between different processes, but between a group of processes. So that means if one VPS is like twice more powerful than another VPS, that VPS will be able to use 66% of total CPU power only with a single process, while another one will be using 33% of CPU power, like regardless of how many processes it has. So it's not management on per process based, it's management on per VPS based.
So how do you switch between VPS?
What exactly do you mean?
I mean,
How do we switch between?
PM. There are one PM, and there are several partitions, right?
Mm-hmm.
So how do you switch partition A to partition B?
You mean switch in terms of CPU? CPU scheduling?
Yes. Yes.
How exactly it's implemented is it's just a virtualized run queue. So instead of on physical system, you have one run queue per CPU.
Yes.
In VPS, you have own run queues between own run queues for different VPSs, And then CPU scheduler is basically schedules those run queues on different physical CPUs.
Suppose we have only one CPU and we have several partitions.
Mm-hmm.
Each partition has several processes.
Mm-hmm.
So each partition has some kind of run queue.
Mm-hmm.
But you have to switch partitions, right? So there is some partition run queue, kind of.
Right. Basically, where is scheduling of processes inside of one run queue of VP inside of the VPS, and then where is kind of level virtualization for it. So scheduling of different run queues belonging to different VPSs. So that's how it's implemented.
Okay.
When two-level disk quarter, first level is just limiting of amount of space available for particular VPS, and what second level is user group based disk quarter inside of the VPS. So on standard Linux, user group based disk quarter is per partition. In case of VPS, on the same partition, you may have multiple different instances of user group based disk quarters. What's about, again, checkpoint and migration, which most of them we discussed already. So the main idea is that complete state of the VPS may be saved in file, and then that file may be restored later or can be restored on different server. And basically comparing to migration of live migration implemented in VM-based solution, there are less limitations in that solution, because typically in live migration of VM, you should migrate on the same type of the CPU. In case CPU has a different set of features, VM is very likely to fail on that new CPU because kernel will not be able to work properly because it wasn't properly initialized from the very beginning. In case of OpenVZ, it's much simpler because applications are normally not that aware about particular CPU capabilities and very rarely may fail on different set of CPU instructions. Like as example, in case of Java, it's maybe more or less sensitive to CPU instructions, but simpler applications, they don't really care about different set of CPU instructions on different CPUs.
VMware の vMotion はインチャルからインチャルにハードウェアのマイグレーションは可能だけ可能ですけど、バーチョーズは AMD からインチャルから AMD 問題なんです。
So that screen is just a screenshot from very typical usage scenario. So how you create server, how you use it, how you remove it from the system. First of all, creation. VZCTL create 101. 101 is the ID, numerical ID for that VPS, and this is the name of the template we use. So we just create like new VPS with ID 101. Then add in IP address.
And before
I'm sorry about that. Okay, then start. Starting of VPS, it's normally it's much faster than starting of dedicated or VM-based server, just because you don't need to load kernel itself. Kernel doesn't need to be reinitialized. It's only running of processes and running services in that VPS. So then exec allows you to jump from physical server inside of the guest. And with this command you run. So again, with another management capability, directly from the host, you may jump in VPS context and manage your application, like start, stop services, modify something, and so on. So very simple example, just PSAX, check out the list of the processes. And we see processes running inside of the VPS. So you can see each VPS has its own init, and then just transparent numeration of normal processes. So the difference with standalone computer, normally with those processes starts with unusually big numbers.
How many processes can we have at the same time?
As many as standard Linux kernel allows.
I mean, can we have same PID on different environments?
Basically, yes, you can. From outside, they will be different, but from inside, they may be the same. It's even required for the migration, because when you migrate it, that process ID not necessarily will be free on the computer where you migrate it. As far as I remember, in recent kernel versions, total number of process IDs you may have is, what is that? Can you remind me? It's 32 or 64,000. So normally it's much more than you would reasonably run.
Yeah.
Because, like, if as example, just an example, you have 100 of version environments running on the same physical box, still a lot, and each version environment runs 100 of processes. Still 10,000, still fit that space. Okay, so execution of the process. Then just jumping in VPS context and using shell inside of it. So when you type vzctl enter, that shell command prompt you see is shell inside of the VPS. When logging out, you get back to the host. When you can stop it using vzctl stop. vzctl stop vzctl stop stops all the processes gracefully. So that means it just switches run level of that VPS to run level 6, just shut down run level. And VPS itself stops all the processes. Also, there is a way to stop everything forcibly. You just may specify like stop -- fast. In that case, that means like kill everything without giving applications to chance to shut down gracefully. And then you can just remove the VPS from.
So
yeah.
How do you tell the run level to the client? I mean, what?
That part is just virtualized. So in the same way how you switch run level on physical computer, application may do absolutely the same, but inside of the VPS. So they will also change that run level, but for that VPS only. So each VPS has its own run level.
Yeah, but okay.
Can you show a demo tonight?
Probably can. I just need like 10 minutes in order to prepare.
Yeah.
Okay, and then you can just remove that VPS. So like just full VPS life cycle. Created, run, stopped, removed. And everything may be performed like in a couple of minutes. Templates. So this is a list of templates available on physical host. vzpkg cache allows you to create with tarballs and then create VPS out of that tarball. And this is the way how you install GCC in a particular VPS.
It is
Okay, so typical density. This is like maximum numbers, right? So I mean, it's not production density. It's not really how many you would run on production server, but still, you know, each VPS is actually very small. For a very simple reason, there is no additional version of kernel, and also it shares most of the resources with other VPSs. So density numbers are normally pretty high.
So the OS template は基本的に普通の OS のパッケージ、ライブラリファイル、全部のファイルのシンボリックリンクパッケージになっています。そして全ての仮想環境はそのシンボリックリンクを使っている。
シンボリックリンクハードリンクじゃなくて
シンボリックリンク。
You know, symbolic links, they used only as placeholders for VZFS file system. But VZFS is virtual specific. In OpenVZ, we use just normal files. Symbolic links is not really important that we use exactly symbolic links. The idea is just some kind of link from VPS to file in template, which is transparently converted by VZFS into the plain file. So VPS still see only plain files, normal files, like on normal file system. Some feedback about virtual users, OpenVZ users. Okay, so basically what's all about that presentation. If you don't mind, I probably would show you some brief demo on that computer. Okay, so just give me like 10 minutes in order to start all the required services on my laptop, and then we can just start.
なんか皆さん質問とかどうでしょうかね。はい。
今仮想環境の方の、実行ファイルがシンボリックリンクになっているって言ってましたけど、物理的に実体の方のファイルはどのように操作していますか。シンボリックだと頭のところが多分合わないと思うので見に行けないような感じが違うベースに入っていたり物理的なファイルはどうやったんですか。
多分特殊なマウントポイントがあるんじゃないかと思う。
ちょっと分けなきゃいけないんですけど、バーチャル像というのを有料製品と OpenVZ は違うファイルシステム。バーチャル像は VZFS、バーチャル像ファイルシステムで、そこでシンボリックリンクを使っています。で、OpenVZ は普通のファイルシステムを使っています。で、ちょっと私の理解で説明しますけど、operating system template. Correct me if I'm wrong. 例えば Fedora Core 5。普通の Fedora Core 5は多分、インストールすると900メガバイトですね。普通にインストールすると。例として。で、基本的にそのOS テンプレートは、一番ミニマルライブラリファイルパッケージになっています。で、このターボールはその、ファイルシステムの、私の理解でシンボリックリンクのパッケージですね。で、バーチャルVPS 仮想環境を作るとき、このシンボリックリンクのターボールを このパーティションのところにアンタッチする。で、そのシンボリックリンクはその元のフェドロコファイルの元のファイルに見ています。
でもどこかに実体がマウントされてるんですよね。
そうそうそう。そしてそのアンタッチしたのシンボリックリンクパッケージをマウントする。これをマウントして、でこれは動いてるの仮想環境。
アーカイブされている。オフセットがまじた確認されています。オフセットを入れた状態でもうそのシンボリックリンクのファイル名をアーカイブしているということです。
そうですね。で、そしてすべての仮想環境同じパッケージを使ったら同じパッケージを見ています。仮想として。で、さっきアンドレが言ったのはその仮想環境の中にもしこのファイルを編集したらコピーオンライトとしてこのファイルになります。本当のファイルになる。このディスクスペース。そしてこのパッケージで仮想環境でフェドロコファイルをインストールすると25メガバイトフットプリントかかる何百円。
ルート X。
チェンジルートとか JL の実装ってのはどういうふうになってるんですかね。
あれはまた違うものだ。
違うもん。
チェンジルート
チェンジルートは頭変わっちゃうから。
頭変わっちゃうから、
頭変わっちゃうから必要な環境はその次にもう一回持ってこないと持っていかなきゃいけない。
ユニオン FS それ。
ユニオン FS。
ユニオン FS みたいなのかな。本当かな。
It looks like a Union FS.
Not exactly.
Not exactly.
No, it's not, Union FS is another way how you could implement very similar capabilities. It's just like you may have like read-only image mounted from one side and from another side read-write and every change you may store. But you know, in Union FS there is a problem with rename as example. Like directory rename is really complicated operation in case of Union FS. Normally you need to copy everything.
The idea is very similar, right?
Right, but implementation is kind of different.
Yeah.
Right. I mean,
but okay.
and then in Union FS is very simple, like to create copy and write files, but it's not that simple to provide like fully capable patch management. So what exactly I mean in case you have VPSs, two different VPSs with two different patch levels, you basically need to manage to mount them to different instances, different copies of that read-only image. In VZFS, it's much more flexible because you may manage everything on per file basis. You may remove one link and create another one. So it's just more flexible way.
So it is implemented in Catalyst, right?
VZFS?
Yes.
Yep.
But it is corporate, right?
It is.
でこのマイグレーションの時、新しいハードウェアの時にこの OS テンプレート、同じ OS テンプレートここに置いたら、その OS テンプレートをマイグレートしなくてもいい。データだけ。そして同じようにメモリー、プロセスを移行すると、そのデータだけ移行する。
でそのマイグレートする時の OS は同じバージョンじゃないとダメなんですよね。
こちらでそのフェドロコ5バージョン1とかバージョン2テンプレートこちらに
いやその下にある FC5 の下にあるその
要は同じレベルでヤムが当たってないとダメなんですよね。
そうですね。
そのままですよね。
こちらで同じとアプリケーションもその